Hi guys, welcome to 5 Mantra. Now we are going to discuss about the data types. These data types are fundamental thing for high level languages, and it is initially developed in a C language and it is used in other languages, whatever so called existing language, Python, C++, C Sharp and Java. Now this is what is the data type. If you go into the discussion, this data type is one concept which is used to allocate memory inside the computer, and how much memory we have to allocate for particular input, and whether it is suitable or whether it is a wastage of memory. These two are important factor whenever we are allocating the memory. For example, whenever you requested to user, please enter your age, maybe he will enter 2 digits number, maybe sometimes he will enter 1 digit number. He cannot enter 4 digits or 10 digits or 20 digits number. Why? Because we know age characteristic is 2 digits. Now I want to save this number, how much memory is required for that, and how this number will be saved inside the computer. Okay, that will be explained with the help of data type concepts. And whenever using data type, here one important thing is that, okay, that we called as an identifier or variable. And with the help, what is the use of identifier is, it will identify that memory location where user data is saved, and how to give the name for that allocated memory is a very important task, right? So here, whenever we are working with the data type will give the memory location address, memory location size, and that size will be allocated by your compiler. Now what you have to do is, you have to recognize that block at runtime. How to recognize that block? That is done with the help of variable or identifier. Now how to define this identifier or variable which is point that particular memory location is, with the help of syntax. And here the syntax explains that here data type is the first part you have to use, and after that you have to give the variable name. When we do this, variable name will point to some particular memory location, and whenever you request that runtime, that memory location value will be given to your program, and that your program will be used that, and it will do some operation and it will give the end result to the end user. This is the scenario actually follows. And variable name is nothing but one identifier which identifies the application inputs. Okay, now deeply we'll go into this discussion. See that here, now basic question is, if you observe the data, sometimes user will give different type of data. Okay, maybe he will give the single digit, maybe he will give the 10 digit number or n digit number, and maybe he will give the single character, maybe he will give the more than one character, and sometimes he will go with the images, sometimes he will give the video files, audio files and all. And how to get this data, that is important. Okay, and using different languages we have a different technique, but all languages follows this data type concept only. And this C language, we have some restriction on input data. In a C language, whenever we are working with the C language, we have to remember that the C language is developed in a DOS environment in 1970s. That time we don't have that much infrastructure to save, to retrieve, to use this different data like images, audio files, video files and all. Now what data will be accepted by the C language? That is important, right? So if you go with that, C language only accept the data is fundamental data type, only which is entered with the help of keyboards. Means whatever symbols we have in a keyboard, all symbols will be accepted by your C language compiler. Means it can allocate the memory and you can use it and you can manipulate that data. And basically how this data is divided is will be explained with the help of data type. Means it will be explained how much memory is available for that data type, and how to access the data type, and how to dump the data type data into the memory. Okay, basically this is the three types of data types we have in a C language. Okay, basically how many? Three types of. Now if you see that fundamental data, whenever we blindly, if you see that, okay, what is the basic data will be given by the user using keyboard is only you can give numbers or character symbols. Right, maybe it is @ symbol or something like, okay, either 0 to 1, 0 to 9 symbol, or some numeric alphabets and special characters and like this. And whenever you are getting these data, some memory is required, right? Sophisticatedly they divided into different parts. Okay, and they given that they given one unique name. That name is nothing but a primitive data types. It is a fundamental data type. This is the base for C language. Whenever you want to develop any type of application, you have to depend on this base. Okay, and after this primitive data type, we have another data type, and they are extended some features. Using this data type, they are extended some features and they given a new name. That is nothing but a user defined data type. Means user can define his own data type. Why? Because sometimes fundamental data type can never be fit for your application. Okay, to get better application, you can define your own data types. Okay, that is explained by the user defined data types. And third one is very important, and it is extensively extended in other programming languages also using these. Those are derived data types. Means here multiple of these data type, using this multiple of primitive data type, we define user defined data type. But here derived data type is that only it is used primitive data types as well as user defined data types. Means here mutually you can go into that, right? You can create derived data types, you can create using primitive as well as user defined, and you can work with the user defined data with the help of these two also. That much flexibility we have in a C language. Because of that, lot of extension we have in a C language. If you see that, so many implementation was there. Okay, you can create operating system also with the help of C language using these data types only. That was advantages we have. Now at glance, okay, initially it is not right time to discuss all data types, but at glance, if you are preparing interview purpose or something, if you want to know what are the data types we have, if you want to list out, these are the basic list out. Now see that primitive data types are these. One is fundamental data types, I said, right? Now if I say fundamental data means on character keyboard you have a numbers or special symbols. Okay, you have a numbers and special symbols. That numbers and special symbols will be recognized with the help of character. Now I want to give a big number 256, 347, like 2,347,000, like different numbers you want to give. You want to save the population of Indian or any country population. It is a big number, right? For that you will go with the long integer or integer. Now I want to save pi value. Mathematically you know pi value, right? That you can save into the float or double. Like how many fundamental data types? 5 fundamental data types. These are the fundamental data types we have, and these data types are divided into different parts that individually will discuss each type elaborately. Right, next one is user defined data types. See that struct, union, enumeration, typed of, these are the keywords we are using to define user defined data types. Programmatically, you can create your own data type and you can use as how we are using a fundamental data types, same way these data types we have. How many things? Structures, unions, enumerations, and typed of. Next one is derived data types are strings, arrays, and pointers. If you know these concepts, half of the subject is over. If you are perfect with this, everything is clear. First, we'll start with primitive data types. This primitive data type is very important. With the help of primitive data type, we can do different type of programming, basic programming things, right? What are the primitive data types we have? We'll see. Already we know that 5 primitive data types we have. One is the integer, character, float, and double, and long. These are the 5 primitive data types we have. Now, basically, if you go with that first one for most important and very small data type is nothing but a character. Okay, it will be represented with the help of char. It will be represented with the help of char. Whenever I want to represent one character, that will be defined inside the single quotes. Okay, that will be defined with the single quotes. If you see that what data you will accept is, okay, maybe it is a special characters or capital letters or small letters and numbers, anything which is enclosed in a single quotation, that we called as a character. And it will be represented with the help of unique name. That word we called as a keyword, that is nothing but a char. Okay, and next one is another data type already we discussed, that is the integer. Okay, whenever we go with the integer, okay, how it will be represented means that is nothing but a int is a keyword we are using, and with the help of keyword we can allocate the memory. How much memory you will allocate? 2 bytes if it is a small integer. Whenever user is given small, that time we will allocate small amount of memory, that is nothing but a 2 bytes or 16 bit. Maybe sometimes user will give large data like, and that number will be given with the help of long int, and memory will be allocated 4 bytes. That is a 4 bytes. And if you see that other data example, how to read which data will be accepted means any number, either it is a negative or positive. Negative number or positive number means with the same amount of memory will be used for negative number and positive number. And how this negative number will be represented, that we'll discuss elaborately. Next one is float. This is the float data type, and which is used for floating values, and sometimes pi number I want to save, or sometimes you will save your average of your marks, or average of your sales, average of your salaries, and these things whenever you want to get, you will get a floating values. And how to represent it means that will be represented with the help of keyword, that is nothing but a float. Okay, with the help of float keyword we can represent the decimal value. And what is the size of here it is, whenever if you see that float value, we have a 2 numbers like 2.40, like 2.40, 2 is the one number, 40 is the one number, right? These 2 number will be represented with the 2 bytes and 2 bytes, that's why it's a 4 bytes. Okay, next 8 bytes is nothing but a, whenever I want to represent a big number, right, that will be the 8 bytes. Okay, that we called as a double. Now I want to represent memory allocation for my data types. Now basic data type is nothing but a character. Now I want to save this character data into the memory, and whenever we want to save, one format is important. Already I said one format we are using, that is nothing but a ASCII value, right? Now this ASCII value will be represented of all characters, and that ASCII value we called as a American Standard Code for Information Interchange, right? This is the important format we have. This is the universal code for all programming languages. Okay, and the next, after this we have another standard we have, that is the Unicode standards. Okay, that is a universal code, right? There we have large representation of data, but it is a basic representation. In this basic representation, I can save, I can hold 256 characters. Okay, 256 character means I can save from 0 to 255 numbers I can save. Like, means if you observe this, how much memory is required for this number, if you know, easily you can work with the data type. Means how much memory is important to represent one character. Okay, if you know that, that is nothing but a size of the your fundamental data type character size. Now if you see that you have a numbers like 0 to 9 symbols you will use, these are nothing but a numerics. Okay, now this numeric you will use for represent numbers. Maybe you will give one time, maybe 1, or maybe 1 2 3 4, or maybe 12.34, or anything. This is the numbers you will represent. Now if you go with the characters, okay, maybe you will go with the alphabets A to Z, and small case it is A to Z. This is the one representation we have. Here each character is nothing but 26 letters you have plus 26, and this is the 10 numbers. Like, basic representation is this. And if you observe the keyboard, you have a lot of symbols, or each symbol have a unique name in a ASCII value. Like I can represent 256 characters using ASCII values. Okay, ASCII representation inside the character variable, I can hold 256 characters. This is the main important point you have to remember. Okay, and if you see that what are the characters I can represent, and how to say how that character will be saved, if you know, easily you can work with the data type, right? This how to save these characters inside the memory location is important. You know that all memory locations are represented with the help of bits. Like I want to represent one memory. Okay, I want to represent one block. Like this is the my memory location, and if you see that each will be represented will be the one block. Okay, like each one will be represented with the one unique digit number 1 2 3 4 5 6 7 8, so on. Like, okay, this is not required for our requirement. Now these are the 8 bits I have. Now I want to dump my data into this. Okay, and why? Because character holds 8-bit data. Okay, maximum how much data I can dump into this is that already I said 256. How it will be, that will get into the simple analysis. Now you know that whenever we are working with the binary data, when you want to convert binary data into decimal number system, that we have a 18421. This is the important formula we have, right? Is the first one is everything is 2 to the power of 0 to go on, like 7 till 7 we have, right? If now 2 to the power of 0 is nothing but a 1, and like 2 to the power of is nothing but a 2, and 2 to the power of is 2 is nothing but a 4, 2 to the power of 3 is nothing but a 8. Like, if you elaborately, if you discuss this concept, see that here you have 2 to the power of 0, next this is the 2 to the power of 1, next 2 to the power of 2, next 2 to the power of 3. It is a simple way you can represent, like 2 to the power of 5, 2 to the power of 6, so on. It is the last digit 2 to the power of 7. If you see that this is the first digit, second, third, fourth, and the fifth, sixth, 7, 8. Remember, your power will be start from 0, because of that it is end with the 7. End with the 7. Now, what is the 2 to the power of 0? It is nothing but a 1. Next, what is the 2 to the power of 1? It is nothing but a 2. And what is the 2 to the power of 2? It is nothing but a 4. Right? And what is the 2 to the power of 3? It is nothing but a 8. Next, what is the 2 to the power of 4? It is the next one is 16. Same 2 to the power of 5 is 32. Next one is 64. Next 128. This is the maximum representation I can do. Right? This is the maximum representation I can do. Like if I represent 1, 0, 0, 0, 0, O, O, 1, 2, 3, 4, 5, 6, 7, and last digit is also 0. Now what is the big number? Now if you see that this is the 128 is the this one, remaining will be the zeros, right? Remaining will be the zeros, so on. This the result will be the 128, means this is the maximum. 128 is the one. Next, another representation I'm doing. See that. Now, if you see that another representation, this is the another representation I am doing. Here, if I put a 1, and here if I put 1, and all are 1, like 8 ones we have 1, 1, 1, 1. Like if you total calculate the thing, add all numbers, you will get 128 and 127. If you observe this, okay, 1 plus 2 is the 3, 3 plus 4 is the 7, 7 plus 8 is the 15, 15 plus 16 is the 15 plus 16 is a 31, 31 plus 32 is 63, 63 plus 64 is nothing but a 127. If you calculate total, this is a 8 plus 7 is nothing but a 15, and this is the 5, and this is the 2. Like maximum is bigger character I can save is 255, that number, and the smaller one will be the all are zeros. All are zeros. If it is all or 0, it is nothing but a representation is nothing but a 0, and this representation is nothing but a 255. This representation is 255, and the small representation is the 0. Right? This is the means how many numbers I can represent 0 to 255. That is nothing but a 250 character, 6 characters I can represent with the 1 byte. And this is the limitation of a ASCII value. If you want to represent more symbols, you have to go with the Unicode. That C language never supports that Unicode. So we have to use this one only. That is the drawback we have. Why? Because the C language is developed in the 1970s. Okay, by Dennis Ridge, right? So in the 70s, we don't have infrastructure to get large data also. Because of that, we have small restriction we have. But this is the fundamental, and it is the base for all data types, and still other languages also have these data types, and one new enhancement was there with the new features with the new data types. But these are the primitive data types are common in all languages. Character is the common. And whenever you want to represent a character, remember that you have to save ASCII values, and each character is represented with the unique number, and that number we called as a ASCII value. And if you want to see elaborately what ASCII values we have, example way, if you want to see that, now I want to represent the A is a 65 character. Say A is a character that represent ASCII value is nothing but a 65, and the same as a small a is having another number representation, that is a 97. Next one is the I want to save the 0 into the character. Already I said 0 to 9 and a to capital A to Z and small a to Z, right? So same, these three numbers I want to represent. How this number will be saved inside the memory, that we'll see that one. Before that, how, just at glance, how, what is the value we have, that we'll see. 256 is not required. Remember, 256 is not required, so please don't consider that. Okay, and now I want to save the A is nothing but a 65. This is the 64th bit, and next one is the 1 bit, and 97 is the 64 plus 32 is nothing but a 96 plus 1, 97. Okay, same way if you see the 48 is also same. This is the 48 character, ASCII value is the 0 ASCII value is the 48, and that will be saved in this way. Okay, this is a simple way we are doing the memory allocation for ASCII character, ASCII values. Okay, in the simple way we are doing the ASCII values into the memory. So this is the character set. It is very important. Remember this point, right? Okay. And you can ask the one thing, I want to save big character. Okay, 256 characters, how can I save? And here you will get a confusion, right? So here, once again, character set is divided into further way. One is a signed, another one is a unsigned. Signed. I want to represent the characters, but in a small amount of memory I want to represent 256 characters, and how to it is, that how we can save, that I said, but how to make differentiation, that is very important, right? And basically these characters are saved in a numerical format only, right? And here this character is further divided into two types. One is a signed character, another one is a unsigned character. What is that? That we'll see that. If you see that character, this is the memory block I have. Now I want to save some characters like whenever you want to save any character, that will be hold 8 bits. See that, 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. This is the representation what we have. Now, here, whenever we saved any data into the memory location, it follows the MSBs and LSB concept. Means here, most significant bit is the 1, another one is the least significant bit. And how to save this data inside the memory, this will be it will be defined. Now when you, in C language, when you assigned any value into that will be start from low value will be saved into 2 to the power of 0, and highest value will be saved into the 2 to the power of 7. Okay, and this we called as a MSB, and this we called as a least significant bit. Most significant bit and least significant bit. These are the two important bits we have. And this MSB is used to represent sign of any number. Sign means, if you see that we have two signs, one is a plus, another one is a minus. And these two signs I want to represent. Why? Because I am saving inside the I am saving inside this memory, I am saving the numbers, right? These numbers we have a plus positive numbers and negative numbers, but in a characters also we have positive characters and negative characters. Exactly, we don't have that, but representation is there. We are depending on numbers. Because of that, we have a signed character and unsigned character. What is the main criteria when I have to say take signed character, when I have to take unsigned character? This is the basic confusion we have. When you are working with only 127, basic 120 or 10 to 127 characters only, go with the signed. Okay, go with the signed. When you want to represent extended ASCII values, like all 256 ASCII values you are using, that time go with the unsigned. And basically in a C language, everything is a by default sign only. Remember, basically everything is a signed. No need to represent explicitly. That will everything will be the signed only. Means automatically it will take signed only. Here we have a representation like A. If I represent this value will is nothing but 97. 97 will be represented with the help of 64 will be the one, and the next one will be the 32, and a 0 0 0 0 0. So max you can represent 97. If you put all values into the if you put all values into zeros, if you put all values into ones, then what value you can save max is 1 2 3 4 5 6 7 8. This is the maximum number you can save. Okay, 1 2 3 4 5 6 7. If you see that it is the 64 plus 32 plus and what is that, next number is 16, next 8, next 4, next 2 plus 1. What is the value? If you see that 64 plus 92, 32 is nothing but a 96. 96 plus 16, if you calculate, total value will be the 127. In this way, total number will be saved. Means maximum I can save if you left this MSB for signed. Okay, for signed you can save 127 characters. Means for first minimum digit will be the 0000, that is a 0 to 127 characters I can represent. Okay, most characters will be fit into this block, but sometimes extended characters if you want to use, you have to go explicitly unsigned character, that only available in a C language. In other language you don't have that. But when you are working with the C language, and when you are working with when you want to create operating system or this type of applications, go with the unsigned characters. But normally we'll go with the signed characters only. Okay, it will fit. 127 characters are enough for us. These are the basic characters for ASCII value, which have a ASCII values, and all character set will be represented with the help of 0 to 127. And by default, everything is assigned data types in a C language. So this is the important concept to remember. And in a C language only we have a signed characters and unsigned character only for memory representation. Okay, to utilize memory optimally, we have a signed and unsigned keywords we have. With the help of that, we can utilize memory optimally. This is the main advantage. Thank you.